Hey everyone, welcome to lab. So if you don't know me, I am one of Dr. Ku's TAs, and I know that this is kind of weird. We're all gonna be getting through this together. This is new for everyone. So I'm gonna go over what we're gonna be doing today. We are still going to be doing the lab questions and the lab report at the back of the chapter. We're going to be doing those as well. And everything is going to be due a week from today. So next Tuesday, I don't know what the date of that is, but just like a regular lab, everything will be due on the same day. And then if you haven't turned in your guys' homework yet, be sure to take a picture of it and send it to your individual TA. So I'm going to go ahead and get started. There are a couple experiments that we're going to do in here, that I'm going to do in here, that you guys are going to watch because you guys can't be in here. So we're going to be doing Chapter 11, so this is Introduction to Oceanography. If you want to flip to that, if you have a book, it's 185. And if you don't have a book, hopefully you have your group members' numbers, and if you don't, if you have no way of getting the pages that you need, you can email me. I'll include my email in the comments. So yeah. So 11.1, I am going to have you guys do that. 11.1a. So basically, if you want to flip there, it looks like this. And it's just giving you a map of the world, basically, and it just has blanks, and you're going to be filling in the oceans and other major bodies of water. So that should be pretty easy. I'm going to have you guys skip 11.1b. I'm going to have you do 11.2. So if you flip to that page, which is 188, it's having you do a little bit of math, but it shouldn't be too bad. It gives you the formula right at the very beginning. So it says ocean depth. That's what we're calculating in this. So ocean depth equals half of 1,500 meters per second times echo travel time. And that sounds kind of confusing at first, but if you look at the actual question, it gives you, it says 5.2 seconds, 6.0 seconds, 2.8 seconds. And then you just plug that number in to echo travel time, calculate it, you're done. So that's number one. And then number two, it gives you this whole chart of numbers, and all you have to do is flip to the next page and graph it. So that should be pretty easy. I'm going to have you guys skip 11.3. It is worth looking at it though, but I can't have you guys necessarily do this because I know not all of us have a book, and so it would be really hard because you have to circle things and label things, so I'm going to cut that out. But if you have a book, I would definitely look at this, and if you know people in your group don't have a book, definitely send them the picture and the questions, but don't worry about answering them, turning them in. All of your lab TAs will know that we're skipping all of these, so you'll be fine. But definitely make sure, like some of the questions, it's important to know like what a seamount is, abyssal plains, continental shelves. That will be part of the lab report, I believe, as well. So just make sure you can like look that up on Google. It'll show you pretty easy. So 11.4a, that is one, as you can see, that requires an actual experiment, and that's what I'm going to be doing to show you. And we'll kind of go over those questions together so that we can all have the same thing. 11.4b, all you have to do on this one is graph what's given to you. So that's the first part of it, and then there's just some questions. So I'm going to have you guys do that one. 11.5a is the next one that you guys will watch me do the experiment. And then 11.5b, don't worry about that. We're just going to do 11.5a, and then that's it. And then you'll do the lab report at the end. So just to clarify, what you guys are doing is 11.1a questions, 11.2, 11.4a, which I will do, and you guys will answer the questions, 11.5b, and 11.5a. So not too much. I did cut quite a few things out, but yeah, so we're going to go ahead and get started with 11.4a. So if you want to flip there with me, it's 191 in your book. So what we're going to be doing is understanding salinity and density. So salinity is how salty the water is, and density is how dense it is, basically how heavy it is. And I'm going to kind of be showing you that today. So in these graduated cylinders is just fresh water. I have 3 of them. And I have, if you see in the book, it talks about a solution A and a solution B. So I have my solution A right here. This is salt water. And what I'm going to do is all of these graduated cylinders have 90 milliliters of water. They all have the same. And what I'm going to do is pour half of a test tube with my solution A, which again is just salt water. And then what I'm actually going to do is add some of this dye. It's called methylene blue. I'm just going to add a few drops to it and stir it just so that you guys will be able to see it, because over video it's kind of hard. So I'm adding this dye, and then we're going to test how long it takes for the salt water to sink all the way down to the bottom of the fresh water. So we're going to time it. Let me get my timer. Then as soon as I start pouring it, I'm going to start timing. Start. And so, if you guys can see, that sunk really quickly. I'm going to stop it because it's already down at the bottom. That only took 9.9 seconds. So if you flip to page 192, just the back of that page, for solution A, time trial 1 in that little table, just write 9.9, and then that's good. And then I actually did the second, well, I did the first trial, and so that one was 9.5, and then this was actually time trial number 2, so you can write 9.9 in that. So solution A, time trial 1, 9.5, and time trial 2, 9.9. So that was for the salt water, solution A. So as you can see, it sunk really quickly. So what we're going to do now is solution B. We're going to do the same thing, but we are going to add fresh water to see if it sinks as quickly, or if it goes slower, or if it sinks at all. So in this one, same thing, half a test tube with my solution B, and then I'm going to add a few drops of a red dye called Congo Red. And then we're going to stir it. Okay. And then same thing, I'm going to get my timer. And then, if you guys can kind of see it. Okay, I'm going to start it as soon as I start putting it in. Okay, so if you guys can see that, it did sink, but it's not all the way at the bottom. So the red, okay, I have a red shirt, so that doesn't help. The red kind of stops somewhere right here, so we're going to see how long it takes to get all the way to this bottom part. So if you can see, it's still kind of like right there. So it is taking a much longer time than the salt water, which went pretty much completely straight to the bottom. And it's taking a long time. Okay, we're just going to let that wait. Hopefully you guys are all being safe and social distancing, and again, I know this is kind of a weird time for all of us, but I'm glad that we can at least do this so that you guys can kind of see what's going on. Okay, so it's still sinking. It's still not completely at the bottom. If you can see that, there's still pretty much that like area that's still completely clear. So far it's been 1 minute and 20 seconds, so it's going a lot slower. Okay, I'm gonna come back to you guys when this is all the way at the bottom. Okay, so we're back. As you can see, it has gone all the way to the bottom. And for my first trial when I did this, not recording, I got 3 minutes and 55 seconds. And then, so you can write that in time trial number 1 for solution B. And then for this trial, time trial number 2, I got 3 minutes and 49 seconds. So you can write that. And then we just have one more to do, if you can see on there. It's solution B plus salt. So I'll move this out of the way. So my last graduated cylinder with 90 milliliters of water. And in this test tube, we're going to add same thing. Half of it filled with just fresh water, solution B. And then I'm going to add half of a teaspoon of salt to see what that does to our experiment. I'm going to add that. Kind of mix that around.
You just complete ENV151L.
Mm-hmm. I'm recording right now, Koo. There's Koo.
Hi.
Okay, so continuing. We're gonna add the half of a teaspoon of salt. And then same thing. We're gonna add some of the Congo red, a few drops. And then we're gonna mix that around. Done with that. Okay, and then same thing as the other trials. Time it and see how long it takes. Okay? I know it's kind of hard to see. Okay, so we're gonna start it now. Okay, so this one has a little bit of salt in it. And as you can see, it is still going a little slowly because it doesn't have as much salt in it as solution A. But, okay, so it's all the way at the bottom now. So we're going to stop it. So for solution B plus salt, time trial 1, you're going to put 28.8 seconds. Okay, and so that's that. So basically, for number 1, just write a brief summary of the experiment. So what did you guys notice? Pretty much the one that sunk the fastest was obviously the saltwater solution, which was solution A. And then solution B, just by itself, was much slower, took a lot more time. And then solution B plus the salt didn't take as much time as just solution B by itself. And it did go pretty quickly, but not as quickly as the salt water. So however you want to phrase that, just as long as you get the main points. And then is solution A or B more dense? Solution B was way more dense. So it went really quickly, had a lot more salt in it. And then how did adding the salt to solution B affect the travel time? It made it go quicker. So that's that for 11.4a. And then I'm going to stop this video and come back, and then we're going to do 11.5a. So just to be clear again, I think I might have messed up earlier, but so just to be clear, 11.1a, 11.2, 11.4a, which we just did, and then you're going to do 11.4b, and then I'm going to do 11.5a, and you guys will answer the questions. So we're going to start 11.5a right now. Okay, so we're going to do 11.5a. I'm going to show you the experiment for that. This one is the temperature density experiment. It's on page 194, so if you go there, you can follow along. So basically, we're just going to be testing how temperature affects density. So the last one we tested how salinity affected density. This one we're seeing how temperature affects it. So I've had this graduated cylinder getting really cold in this ice. And same thing as the last one, I have 90 milliliters. And we're just getting that nice and cold, and then we're going to add really hot water to it. So I'm going to go over and get some hot water. Okay, so that's been heating up at 410 degrees. We're going to add some of this dye to it again. This is the Congo red. I'm going to mix it. And then we're not going to time it, but we're just going to see what happens. So I'm going to pour this in really slow. So as you can see, it doesn't mix. It mixes a little bit, but for the most part, it all kind of stays up here. So I think it's, yeah, for step 3 on your page in your book, it just says to record your observations below. So just like one sentence on what you see. Basically what I just explained is just that adding hot water to cold water does not mix. So now that we see that, for step 5, if you see on there on your page, we're going to fill a test tube full of cold water. So let me get that. We're going to let that chill a little bit. And we're going to put some of the other dye in it, the methylene blue. And while that gets nice and cold, we're going to add just a few drops. And then we're going to stir it again. Okay. And then I'm going to let this sit in here and just get nice and cold if it wants to sit. Okay, so now I'm going to go get another one of these graduated cylinders and I'm going to fill it with hot water. Okay, so again, this one, the hot water's been sitting at 410 degrees. And now what it wants me to do is basically pour all of this into the ice. And we're going to mix that around. You can see all turning blue, all the ice and everything. And then it's going to have us pour this into the hot water. It wants us to just do the liquid, so none of the actual ice. So I'm going to pour this in. I'm going to lower this. Okay. So if you guys can see, what will happen is that the water, cold water going into hot water, will go all the way down and completely mix with the hot water. So automatically you see that the cold water, the blue, goes all the way down, and hot water going into cold water does not mix. So we know that based off of this, cold water is more dense than hot water. So that's basically what this whole experiment is trying to show you. So yeah, on step 5 it says record your observations for the cold water going into hot water. So if you just want to see that again. And then step 6, it just says write a brief summary. And then there's a question on number 2, and then that should be it for 11.5a. Remember, we're skipping 11.5b, so don't worry about that. And yeah, so those are the 2 that I needed to show you that since you couldn't be here for that, you wouldn't have been able to answer those questions. But yeah, so basically everything else, 11.1a, 11.2, and 11.4b you guys can do on your own, and then make sure to answer the questions for 11.4a and 11.5a, which are the 2 that I just showed you. Don't forget to, my lab students, turn that into me, and then everyone else turn that into your TA. If you have any questions, you can email me, you can email your TA, they should know what's going on, and make sure, don't forget to do Lab Report 11 as well. I know it's kind of a lot of work, but if you still wanted to get in contact with your lab group, whether it's FaceTime or Skype or just texting, whatever, you can still work on that together. I'm not sure exactly how the other TAs do it, but you can make sure that everyone turns in their own questions, though, especially now that it's online and it's all kind of funky. But yeah, so just watch out for these videos. There's this one and then 2 more, and then we'll kind of play it by ear. I'll let you guys know. I'll send out emails. And yeah, again, if you have any questions, go ahead and email me. Otherwise, I will see you guys next week.